today we are getting into the real-time FinOps intelligence. We all know that AI space is being rogue in terms of innovations in the latest years, and financial services is no different from any other industries from being impacted in a positive way and enhancing the capabilities, especially the ops part and all as same as the developer productivity side of it. So today, I'm Tina. I work for Microsoft and I work in a team where we drive the financial engine, the trillion-dollar platform for Microsoft. So without further ado, let's jump into the topic and let's talk about the challenges first. So, what happens in the financial platform? So, we are in the realm of a revolution, right? And what was the previous one? It was the cloud services. So, most of the financial platforms which are risk averse were in on premise servers, which were moved to cloud services. And most of the companies that has happened, and still there are like some places here and there which are still catching up. But however, being in cloud services and in distributed world brings its own advantages and challenges. So what do we do here? So we have millions of events coming and we have a high throughput streaming system. So most of the systems are either microservices, Spark engines, and they're being like stored. There are storages like Cosmos or Redis in between, storages in Azure or AWS, whichever cloud platforms which we have today. And we drive observability on top of it, which is very critical. Monitoring and observability are very critical to running the financial systems without outages. And what do we have here? So we have transactions which are high throughput. We have logs coming in. We track some metrics, and there are schemas. So when I say schemas, those are like very domain dependent, right? So if suppose if I am a team which processes the revenue or recognizes the revenue of the company, then I as a team would be interested in few fields, whereas the finance or the marketing would be looking into some other fields as well, together with some of the consolidated fields are populated from one team. So those differ, but what remains the same is the challenges of less outages, high availability, and having minimum latency, and also the auditability when it comes to the tools we implement. So, right now we have automations, we have tools. So, we are at a juncture of finding okay, what AI can do. How can we leverage AI more? Yeah, this is what sort of we talked about, like what we are processing. So, what do we have in hand? So, today, all these systems, whether the transactions, the metrics, and the application logs, all are in different tooling systems. So, we don't have a consolidated place. A dev or an SRE should go to each individual systems and trace the path of a particular transaction when it comes to an outages or an error or why didn't process some transactions. That's the most common question we get. So these are the challenges, and yes, we do have AI, we do have co-pilots, we have authenticated co-pilots integrated to our systems. With some exceptions like high risk financial platforms, still we are not every company is fully enabling the AI access, but with our own guardrails, Microsoft has AI systems enabled, and we fully run on AI platforms with adequate security. Keeping security out of the context for a while. So, given that we are working in a secure environment, what are why the ad hoc prompting fails. The most important, or something as important as prompt, is the context. So context engineering is an entire is a field by itself, and which wouldn't suffice this talk to cover. Even so, we can't even scratch the surface of prompt engineering, context engineering, or the mix of both. But what we carry with us, or what we keep in mind, is that prompt engineering and context engineering go hand in hand. One is not a substitute of other. So I could be a master of writing the best prompts. I would have learned everything what a Cloud Sonnet system or a Gemini model can work through the prompts and give us adequate. Maybe I can even fine tune my model. But then, if we miss the context, then it is the prompts are failing. And why why do you think ad hoc prompting doesn't suffice? It's because I'll be a dev one. I'll write certain prompt, and I may not have all the context on how I should troubleshoot it, or how what I am really looking at. So maybe I am dev working in a different team, or a sister team, or my expert is somewhere else. And dev 2 comes in and writes the same prompt, but they give all the necessary context and the model give is the right output. This is more of a standardization, I would say. So that calls for the standardization of using the AI models across, not only in the space or the DevOps space, it is everywhere. So suppose I'm working in a microservice, and I'm developing some logic around like how I process a set of records or set of transactions, or what is the input, how the output should look like. I would be working and then moving forward to another one, and keep going. But whoever comes in later and makes changes to that system would still have to adhere to the fundamental design of it. So some of those tangential to this is would be like in developer productivity side, GitHub Spec-It is being phenomenal in setting up the guardrails for the project and not letting the developers violate from the design requirements. And coming back to our topic, so missing the context when we get an income. So we know that all these AI models are probabilistic. With the same prompt, there are times where you get different outputs. That could be the context window, that could be how we write the prompt, or like how we write the prompt in the sense that what is the order in which like we analyze a certain scenario. With probabilistic model, inconsistent output is something which should be expected at this point, and I know many of us have gone through the paper published recently about the hallucinations of the model and how that is something unavoidable. Again, that was something tangential to our topic, but I think with the advent of AI, we all have been experiencing consuming huge amount of knowledge and catching up with development every single day. So we all should be used to it. I know all of you are. So, yeah. So moving on to third and fourth, like this will result in a poor level of auditability. So, how I'm going to say or determine the efficiency of that platform which I implemented? So, when ad hoc prompting does all of this will this cause poor auditability as well, and in, it will cause a latency overhead. Now, what is the solution? We should do template driven prompt engineering. Like I said, this is very similar to what HubSpec does in terms of developer productivity, in terms of software development. Why then we are having this talk here on template driven prompt engineering for DevOps as such? That is because of the complexity which we spoke about. Like, I have microservices, I have Spark engines running, I have logs and Custo, I have data in Cosmos. How do I integrate all this? So, in case of a software development, that's not the environment which a software development happens, but DevOps happens like this, right? So, we should have the models should be validated, the designs, the sequence diagrams, the UMLs, everything should be integrated in case of a software development. But in case of an infrastructure and full blown application, we have several components like what I stated comes into play. That is where there should be modular templates. That's a concept where we can use LLM into real automation of financial event streams. High throughput, high availability, minimum latency, all of this could be ensured by modular templates where we as engineers we work on the templates on what needs to be done and what sort of prompts and what context are relevant in a particular scenario. We also implement the policy constraints like what the model should not do. These become very critical in case of like production data, especially when you are dealing with financial data and machine actionable. So this is what something going into the multi-agent system where the output of one system should be actionable and should be in a format which is feedable as input to the next system for another agent to work on. Now, there are the core frameworks. So, like we can create template libraries, and another advantage of doing all this is that we can use source control and have it standardized, right? Then any change would go through reviewers and approvers, which would help the entire team or the organization to standardize the process. And the metadata layer which have all the schema registry, so this comes into play when we have to handle the like anomaly detection in our financial data or like any type of transaction. So that is where the metadata layer it comes in, and the policy engine, so where you can write rules. And you will have we have the output validator to validate the output. And also this is where in the output validator stage is where the dashboarding comes to play. Why won't X6 allow a dashboard where the model efficiency is being visualized, right? So the template anatomy. What happens in the template? What do we have in the template? We should have let me touch upon the operational knowledge first. Operational knowledge and the policy constraints first before coming to the event context and schema reference. So what constitutes the operational knowledge? So when do I see a log, a log message? What should be the next action? So, from the log message, what fields are relevant for the agent, for the AI system to take the next step, or what fields determine the next action? So, this operational knowledge lies in the head of many engineers or SREs today. So, this is AI platforms and prompt engineering, especially, is a great way to democratize the knowledge within an organization. So, once it is written out there by an SME, anyone can use. So, if I am a junior engineer going into a troubleshooting, how I do or what steps I take for the troubleshooting, except for the basics, it could be way different than how a senior engineer would troubleshoot it and get to the results. So, what constitutes the difference is their subject matter expertise, their experience, and such. So, this is a great equalizer, great leveler platform. So, the operational knowledge and this is somewhere like the executives of the org comes to play, and what the leadership thinks about AI platform and how do we enable everyone to be most productive and do more with less. And the policy constraints, and we should have an output format. We determine what should be or how the output should look like. So from the templates to the decision, so when the event ingestion happens, so we ingest events which are like financial events coming into our system. That is where the templates come into play. We can route it using semantic kernel, which could be a Microsoft agentic framework, where and we can write plugins where plugins and the agent can route the request to several plugins. So that is the software part of it, the middleware part. And the templates are the prompts. And what do they act upon? They act upon the logs. And what is the corpus? The corpus will have all the docs, the designs, the code, everything embedded and vectorized and stored in a vector database. So that, and then we can deploy an LLM model to process the request or to process the logs, right? In between, it happens what happens is the context injection. So the context injection to a great part would be a part of the agentic framework too, and we can write the software to route on the context selection of the model of the entire framework, I would say. And then we can do necessary validations and come up with an action item. So, what would be the action item? The process doesn't end here, right? The action item could be like, okay, I have to replay these orders, or I have to delete some duplicates. So there should be an action or which can be automated enough or enough for the agent to perform by itself or go through an approval process. So, what do we gain here? So, these are production scale. Like we know, with the advent of cloud itself, millions of transactions or millions processing has been like a very common phenomenon with the capabilities of distributed computing. So we get the same benefits here, and we get reduced latencies. And once you build a framework, all you do always is to build on top of it. And what we need to do is only to update the models when the new models are in the market. And by by using a well balanced combination of context engineering and prompt engineering, we are not, the organization is not investing in LLM. That would be just reinventing the wheels. We have best performing LLMs right out in the market, and they are all, we have them out of box. So all we do is to tweak it to our own requirements. So this the for the platform teams, the most critical component or critical function of platform teams is to maintain the systems at high availability, which AI comes pretty handy. These tools comes pretty handy, and they have proved to be phenomenal in the results. And we can automate. So adding the context and having the prompts, creating this automation workflows will give us more control on what we do, not let the model just go haywire and do whatever it wants to or whatever it thinks is right, rather than the SREs and the platform teams have a better grasp or better grip, better control of what these systems do. What are the considerations? So, where do we start here? So, we can start with a most common problem, right? So, this is where we go with the 80-20 rule. Like 20% of the problems we solve, we give an 80% gain, right? We pick some use cases which are like very frequent and are at the same time causing a lot of toil to the DRIs. And integrated into the system, we connect it to the observability platforms and at the same time implement fallback mechanisms until we know the performance, until the performance evaluation is fully done. And it is best to have establish a feedback loop for improvement. That could be like ad hoc also, right? That need not be integrated at the very beginning. We can get the feedbacks, validate, get the results, validate, take the feedback, and that could be like on time processing. So in case of the vector databases, like people like engineers, the teams are continuously adding more documentation. So how do we how do the model becomes stale if it works on the previous data? And some of changes could be like critical, right? So how do we change that? So there should be a pipeline, a separate pipeline to populate and do the vectorization and store it and update the database. So those will be like feedback loops which can sustainably improve the performance of the model. Like we said, we should have to maximize the template effectiveness. We are like teams with 40 or 45 engineers working in an application. So version control becomes very important. And we should have a modular composition of the templates rather than write in a one big file, everything. So the advantage of prompts is that like that again, that's like a separate, that could be a separate session in itself. We modularize the prompts and at the same time, and later we can refer the prompt files so that the module can check for the file. So that is something which we touched up on a bit on the agent while talking about the agentic framework. Now, extending the framework, so we have a lot of cost gains, especially a lot of man hours would be saved by automating these workflows, and we can implement the risk evaluations for our platforms. I'm sure you all would have heard about architected frameworks. AWS and Azure have their well architected frameworks, and many teams leverage those frameworks and have agentic model evaluate their applications to for the agent to validate the security requirements, the performance efficiency and cost effectiveness of those systems, and it just churns out the results. So those automations have like huge value monetarily as well as efficiency wise. So yeah, that's what the compliance, something which we attached upon, and security, capacity planning. So the resource forecasting and scaling also this models can churn out. So incident triage is one of the main areas where many teams have are highly leveraging DevOps for AI. So, what are the key takeaways? Use your templates, modularize your templates, and put the context in the right place and make sure you audit the performance of the model. With that, I'll end the talk here. It was great to have the opportunity to interact with every one of you, and we all look forward to what's next. What's the next major wave in the AI? I'm also like praising for that. Thank you, everyone. Bye.